taper beam with the opening, and then let's say the curving. So curving, actually, if you see the result diagram, okay, this is the envelope. I tell the envelope. This is the moment. It's a fixed joint to the column. That's why you got the moment here. Shear force, and then torsion. So torsion is quite high output charge. That's why you can see the detailing. There's a torsional detailing inside the calculation. They include this like sidebar, and then torsional link is lapping here. Close link, considers close link. So they give you all the beam in one shot. Actually, just now mentioned to you. So this is detailing generated by the Esteem software. Sabah, if you don't edit anything, you just bring up for construction and it's still to be constructed. That's why Esteem detailing is constructable without any editing. Some software you don't to change something outside the problem. This one is talking about you may change the bar to bigger or the overlapping of the character labeling. Okay, so this set already for the ground floor, so now I start copy out to 1B. So when you copy out first similar floor, so I go to the 1B floor. I need to do something here. For example, the slab, I go to delete all the slab. Maybe leave it just on top of the lid core. And then again, I will go to do the elevation input for the beam opening. But the height of the building, I need to change it here. Let's say it's 4 meters here. Ground floor is 150. This is the real actual height, floor height. So you follow, I change to 4 meters because the brick wall we say is default height. This is follow. Yeah, and then also my top floor, the brick wall. Okay, now it's completed already. Okay, now we let's say you want to do the transfer column, also very easy. We don't have much procedure for the transfer column. So this one, let's say you can delete off. You put the column here. The column is on the beam now. Okay, so last thing I want to show you is a slanting member and a lateral lock. Okay, slanting member, how to do it? This is probably some new features. Slanting member. So slanting member will allow you to connect the member from one key pan to another key pan. They will launch another screen. So let's say GB, I start from here. Then connect it to any floor, not necessarily one floor, but you can connect to third floor, fourth floor. Just a contact between two floors. You connect to 1B, this point. Okay, close. So actually, it's draw the slanting member. Okay, so now it's ready. One is slanting beam, no slanting slab like renting it's still under development. So, okay, the last one is a lateral lock. So lateral lock consists of wing lock, notional lock as I said, it's some seismic. It's under static that kind of lateral lock. So most commonly we have a wing lock, notional lock is built in. So we can add, let's say I just do two cases. The wind direction blow in 0 degree, that means S to Y, or 45 degree. So now I go to here, computation. So this one, the wind speed, you need to determine, let's say 40 meters per second. So this design wind speed, they refer to the class 2.2 and 2.1. This one is follow the ES6399. Then you can use the auto-generate functions. They will distribute the lateral lock according to the projection area. Like for example, let's say we know 1. This is 0 degree. You see, this is a small point lock. They need to load to the bearing area. They cannot load it to the center of the beam. Okay, we have a 45 degree. So from here you can change also this. Let's say 6. If you is too small, you can put 20. Or you can put extra to the lid core, no problem. This one, the software is just compute based on the projection area, projected area. Based on that formula, to give you the Okay, so now I do the batch process. So batch process, actually I can click until finish, until the pad footing. But I want to stop at the B electron because I want to show you the column detail first, one by one. Normally you can do the batch process from all in, especially if you run 20 overstory, then you leave it, after you go back, you leave it to run until finish. So second day when you come in, you are expecting some results there already. So this one, the cover the 3D also. So 3D, currently I have input myself is 2 lock cases for wing lock plus notional lock. They got 4 directions default, so 6 cases for the lateral lock. Later on you can see the composition of the lock to come up reaction at the foundation one by one. And then you can display the minimum envelope, maximum envelope, lock case 1, service lock plus wing direction, 0 degree, service lock plus wing by 45 degree, all can be displayed to you. So actually after you run, normally we do this like Esteem plus check. It must be passed. If fail, you need to go back. By fail, you will actually they'll prompt you like click. They will navigate for you like where is the member fail already. So now I do the column design. So column design actually there has some parameters. This one normally we need to go through like rebar, minimum rebar, 0.4. You can change to 1%. Also, we default extra 10%. This one can be turned off. If it's not code requirement, you can change it. So, this is a column also. We'll consider all the cases and then choose a maximum emanation. Okay, so this is all the column. Including V-shapes. This is a transfer already. This column is opening. So we have 22 columns, too many. Just right click, as I say, group it. I can group it now become less already. This column actually a lot under this group. Of course, you can go to see the result diagram and see those moment. This one can see the top result, envelope, different column. This one you can have a study on the what we so-called how is the behavior under this composition. So envelope, and then you can see that the top result also. So after the column, we can have a shear wall. So basically, I show you already the shear wall when you create the opening. That is, they will check for the top part. That portion is called couple beam. They check the moment for you, and then they will handle separately. So the detailing line, this is the lower floor, this is the full built inside the ground, and then when you come to the first floor, this is the opening. They give you the trimmer bar, U bar, all this elevation view, U bar and trimmer bar. So this part actually they design for you as a beam. They check for the beam, even though in my case 2 meter with the opening about 1 meter is not critical, but we don't know the user sometimes. This part only 800. 600, but the opening is 6 meter. So 6 meter you carry the slab, you may fail in moment because the failure mode is need to determine. Some software you define this is a column, you design this a wall, they don't check any moment for you because this is a complex element. But we do check for this one. Okay, now we come to the pad footing. Pad footing, you're talking about the bearing, is default is 100. You can change the other value. this is a so normally they give you this column number, column 18, P18. This coincident because like this one C17 and 10. So give you the loading. Then of course this 17 is what size. And then similarly they give you the section. This one they can group together same size. But the difference actually you need to set after 2 meter is 2.1 or 2.0. You can do the interval to control not too many type come up. That means the interval you can increase bigger, larger. Okay, now we go to the piling. Piling we can choose a pile based on this schedule. Then you can amend the pile's capacity, or you can combine two types. Heavier one using 200 square, less loading using 125. So combination is acceptable. Then from here actually, my case I choose one only because it's very light. Even 125 they give you maximum 2 or 3. So like this is a column at 4D. You can see the load combination. This day load, live load, service load, lateral load. So if purely lateral load like wing load, 0 degree, 45 degree, no channel load, some go to negative. So normally if you're talking about a load combination, you will be, let's say I choose a what type of combination, maximum and a load. So then you can design. Okay, so this one also same. I give you the power number. This one P6. So P6, you can give the detail here. Because triangular shape, you got this kind of distance dimension. P6, you see. Section is in one. So this one, if you have power eccentricity, you need to use another accessory software e-booking to do that. This one is considered the standard position without any eccentricity. Then if you have power failure, you need to replace by another power, also need to use another software called e-booking. So now you can see my how we call it, the peg footing now is follow the size already. And then you can change to power, so power. And then you can apply. So this one is okay, so beside this, the 3D view also, from here you can see a lot of things. So remember just now I say, once a pin got opening, they do the meshing to end up for more accurate result. Then from here you can see the placement. Let's say the placement you can amplify 500 times. This is a dead load. Let's say you go to the wing load one, the difference already, so all can be seen.